At first glance, a train seems entirely straightforward, a locomotive pulling a long string of cars down a steel track. But if you take a closer look at the rolling stock, you will discover a highly sophisticated world of engineering, where every single car has a unique mechanical blueprint. While locomotives provide all the tractive effort from the front, rear, or middle, the unpowered cars they move are custom-built to handle very specific cargo and passenger challenges. From high-speed passenger cars to heavy industrial freight and specialized track maintenance machinery, the variety of rail equipment out there is absolutely staggering. Welcome to Machinery Explained. Let's dive straight into the schematics of every major type of rail car. When it comes to moving people, standard passenger coaches with a central aisle and rows of seats are the most common sight on the rails. For high-volume transit routes, railroads use bi-level or double-decker cars to double passenger capacity, though their usage is strictly governed by overhead bridge clearances and the longer boarding times that can cause station congestion. Long-haul routes add specialized rolling stock into the mix, like baggage cars to protect checked luggage, and combined cars that split internal space between passengers and cargo. Long-distance travelers also get to experience diner cars, which act as rolling restaurants and actually inspired the architecture of classic roadside American diners, alongside lounge cars for socializing, sleeper cars that function as moving hotels with private rooms, and dome or observation cars engineered with panoramic glass walls for sightseeing. Even the train crews need a place to rest during massive transcontinental journeys, which is why specialized crew cars are included to let a secondary team sleep until it is time to swap shifts. Moving over to freight transport, the engineering focus shifts entirely to carrying massive weight with absolute efficiency, where single cars regularly exceed 100 tons. Standard boxcars protect general weather-sensitive goods behind massive sliding doors, while insulated refrigerated boxcars use independent diesel motors to keep perishables frozen over thousands of miles. If cargo is light but takes up a massive amount of volume, railroads deploy high-cube boxcars, which feature extra vertical height marked in bright white to warn crews about low bridges and tunnels. For automotive logistics, massive multi-level structures called autoracks are used to ship dozens of consumer cars and trucks directly from manufacturing plants to distribution hubs securely. Flatcars represent the most straightforward design on the rails, providing a simple open platform for oversized machinery, military vehicles, or structural steel beams. To keep long, heavy loads from sliding out of place during sudden braking or rapid acceleration, bulkhead flatcars feature solid steel walls at each end, while centerbeam cars utilize a heavy central spine to support and secure massive stacks of residential construction lumber from both sides. Flatcars also dominate modern intermodal shipping, carrying complete semi-truck trailers or standard shipping containers that swap seamlessly between trucks, ships, and trains. To make container transport safer and more efficient, railroads use specialized well cars that drop the bottom of the container down between the wheel assemblies, drastically lowering the center of gravity and providing enough overhead clearance to safely double-stack containers at high speeds. Bulk materials require their own unique loading and unloading mechanics depending on the nature of the raw material. Heavy, industrial sheet metal coils are carried in specialized coil cars equipped with internal troughs and protective weather hoods to prevent rusting. For rugged, loose cargo like scrap metal, sand, and ore, open-top gondolas act as giant heavy-duty wagons that can be unloaded from above via cranes or flipped completely upside down using automated mechanical rotary dumpers. Hopper cars use a gravity-fed approach for bulk cargo, utilizing sloped interior floors that naturally funnel materials down through discharge gates at the bottom, with open hoppers handling weather-resistant coal and covered hoppers protecting materials like grain, sugar, and cement. For trackside maintenance, side dump cars use powerful pneumatic cylinders to tip the entire car body sideways, instantly depositing bulk materials along the side of the tracks. The largest and rarest cars on the tracks are built for highly specialized industrial cargo or keeping the railroad infrastructure functional. The massive Schnabel car is a multi-axle behemoth that splits in half to carry giant power transformers or nuclear reactors, making the cargo an actual structural component of the train car frame itself. Liquid and gas transport relies on cylindrical tank cars, which are split into non-pressurized versions for general liquids like milk or petroleum, and heavily reinforced pressurized versions designed with protected top-mounted valves to carry volatile gases safely under pressure. Finally, the railroad infrastructure itself is maintained by a specialized fleet of non-revenue cars. This includes ballast tampers that pack track gravel, ballast regulators that shape the stone profile, rail grinders that reshape worn steel rails, track geometry cars that measure rail alignment under full loads, and scale test cars used to calibrate industrial track scales. Even the classic caboose has been replaced by a modern end-of-train device, a compact electronic box mounted to the final car that monitors brake line pressure and uses a flashing red light to confirm the entire train remains safely connected. Every single car on a train represents a highly calculated solution to a specific physics or logistics challenge. Once you know what to look for, a passing train is a rolling showcase of highly specialized engineering.